Hey guys, welcome back. We got number 4. We got to calculate delta G and Kc for the reactions at 25 degrees Celsius. So if we look at this, delta G and K. So how should we do this? Well, I'm thinking we're going to do delta G standard equals negative NF E standard. And then probably I would use E standard equals either R, T, and F natural log of K, or since we're at 25 degrees Celsius in chemistry land, E standard equals 0.0592 volts over N log of K. Either one you want to use. All right. So now we got to look at the reactions. Magnesium goes to magnesium 2+. So that's your oxidation, your reduction. So your reduction is lead going to lead, or lead 2 going to lead. So red is Pb 2+ plus 2 electrons going to Pb. And that cell potential, if you look it up, is negative 0.13 volts. And then our oxidation would be magnesium going to magnesium 2+ and 2 electrons, and that is going to be 2.37 volts. So that means if we combine these, or subtract them, right, I get 2.24 volts. All right. So now we can do our two equations. Now, what is N, though? N, number of electrons transferred, would be 2, right? Because we go from 0 to +2 and +2 to 0, right? It's 2 electrons, 2 electrons. Okay, let's do the delta G first. Delta G equals negative NFE delta G equals negative 2 moles of electrons times 96,485 coulombs per mole of electron times our 2.24 joules per coulomb, which is a volt. So that means if we do this, delta G standard equals, let's see, negative 2 times 96,485 times 2.24. I get negative 43, so I get negative 43225.2.8 joules per mole. All right, well, let's see, that would be 1, 2, 3, so negative 432 kilojoules. All right, and then we have E and K. So E standard, sorry, equals, what's this? Well, we can use the 0.0592 volts over N log K. So we get 2.24 volts equals 0.0592 volts all over 2 log of K. All right, so that means 2.24 times 2 divided by 0.0592 gives us 75.6768. So do 10 to both sides, right? And let's see here. Yeah, 4.7. I get 4.7 times 10 to the 75th. Which kind of makes sense. I mean, that's a huge number, which huge, big negative kilojoules per mole for delta G. That kind of makes sense. All right, same thing happens with B. All right, so for B here, what do we got? We got oxidation and we got reduction. All right, so what's doing what? So O is going from 0 to -2, and iron is going from +2 to +3. All right. And so we have our oxidation and a reduction. So the reduction is, now my recommendation is to use your textbook and to go to your redox potentials, which I think are in your chapter. So in the current edition of the book, I'm on page 917. And if you look, to kind of shortcut this, I got O2, I have acidic conditions going to water. All right? So O2, acidic conditions going to water, 1.23 volts. So it's O2 plus 4H plus 4 electrons going right over to 2H2O. And that standard is 1.23 volts. And then we got iron 2 going to iron 3. We have, and we're going to do 4 Fe2 plus, oh, just going to 4Fe3 plus 4 electrons, E standard. So iron 2 to iron 3 is negative 0.77 volts. So if we add those up, 1.23 minus the 0.77, 0.46. All right, we're going to use the same formula. We're going to use this formula right here. Right there. Same formula. And we're going to use this formula right here. Like how I can cheat like that. That's kind of neat. I like that. All right, so now delta G negative, and what's N? Well, N's 4. And of course we got our 96,485 coulombs and our 0.46. So delta G is what? Let's see here. Negative 4 times 96, 485 times 0.46. Negative, I got negative 177,532.4. And so that's negative 178 kilojoules per mole. We'll go with it. All right. E now. We have what? 0.46 volts. 0.0592 volts all over 4 log K. Solving it the same way, you take your 0.46 times it by 4, divide it by 0.0592, then second log it. I get 1.2 times 10 to the 31. All right, do it the exact same way we did the one before. Finally, C. All right, what's going on here? We got aluminum 0 going to aluminum 3 plus. There's your oxidation. And then we got I2 0 going to I minus 1. So the reduction, right? I2 plus 2 electrons going to 2 I minus. So that would be, so here, let's do it this way. If you look this up, it's written like this. And we have 6 there, so we have to multiply everything by 3, right? So this becomes 3. This becomes 6. And this becomes 6. All right? But E standard is the same of 0.54 volts. Oxidation. We got what? Aluminum. Going to aluminum 3 plus. Oh. Plus electrons, 3 electrons. But we got 2 of those, so it's going to be 6. 2, 2. And E standard is what for aluminum? Negative 1.68, so we flip it, 1.68 volts. So if we add those up, what do we get? 0.54 and 1.68, 2.22. And again, we're using this formula and this formula. All right. So now delta G equals negative 6. 96,485 coulombs and 2.22 volts. Let's see here. So negative 6 times 96,485 times 2.22, pretty big. Delta G, I get, hopefully you got the same thing, negative 128,518.0.2 joules. Make it there. Negative 1,290 kilojoules for delta G. Woo. E, we get 2.22 volts equals 0.0592 volts all over 6 log K. All right, doing the math. Well, let's go 2.22 times 6 divided by 0.0592. I get 225 even. How about that? 225 equals the log of k. And we're going to do 10 to both sides. I get 1 to the 225. There we go. I think that's, yep, that's it. So that is what, number 4. Hopefully that works for you guys. Hopefully you got the same things I got. If you have any questions, reach out. Otherwise, we'll see you the next time.